Okay, so this video is exclusively for October-November crash course students, and as you may remember, in yesterday's class we did till LCM and HCF, and we also learned how to write a number as a product of its prime factorization. And जाते जाते मैंने आप लोगों को बताया था कि perfect square times perfect square gives you a perfect square, and perfect cube times a perfect cube gives you a perfect cube. So that's where we're going to pick up from today. And as you guys know, I have a meeting today, which is why I couldn't keep the class on time. So I'm compensating with this video. So if you look at a perfect square, by the way, what are perfect squares? Perfect squares are basically squares of an integer. Like for example, 1, 4, 9, 16, 25, 36, 49, so on and so forth. These are all perfect squares. And if you talk about perfect cubes, what are perfect cubes? So we have 1, 8, 27, 64, 125, so on and so forth. These are all perfect cubes. By the way, ideally you should remember your perfect squares from 1 to 15, and you should remember your perfect cubes from 1 to 10. This is just going to make life a lot easier when you're doing paper 1. So let's just look at study a perfect square in detail, and I'll show you what I mean by that. Let's take a perfect square such as 36, and let's see what it looks like when we write it as a product of its prime factors. So once you do prime factorization of 13, you'll realize that 36 can basically be written as 2 square times 3 square. Alright, and if we were to write down, let's say, 16 as a product of its prime factors, so 16 can be written as 2 raised to the power of 4. Now here's something that I want you guys to observe. Let's say I write 144 as a product of its prime factors, so 144 can be written as 2 raised to the power of 4 multiplied by 3 square. Yeah. So what you can observe here is, if you look at the powers, you'll notice that all the powers are even. And that's the case with a perfect square. So if you want to have a number as a perfect square, once you write it as a product of its prime factors, the powers should be even. If they're not even, it's not a perfect square. So let's write this note down. In a perfect square, the powers on the bases have to be even. Or you can think of it this way, that in order to make a number of perfect squares, the powers on the respective bases should be even. So what happens if a number is not a perfect square and the question asks us to turn it into a perfect square? Now I'll show you what I mean by that. So a question will look like this. It's going to ask you to write 80 as a product of its prime factors. Alright, that's going to be the first part, and the part that will follow will look like this. Find the smallest value of k given that 80k is a perfect square. Now it could be a perfect square, and later on we'll study what to do if we want to make it a perfect cube. So let's write 80 as a product of its prime factors. So we're going to start dividing by 2. 2 times 40. Let's divide by 2 again. 2 times 20. Let's divide by 2 again. 2 times 10. Let's do that again. 2 times 5. 5 times 1. So 80 can be written as 2 to the power of 4 multiplied by 5. Now looking at its prime factors, we can see that it is clearly not a perfect square. Now let's see why is it not a perfect square and how we can turn it into a perfect square. So 80 can be written as 2 power 4 times 5. Now if I want to make this a perfect square, and given that k has to be as small as possible. Now the only condition that the question will give to you is that find the smallest value of k. It will never ask you to find the largest value of k, because that's technically not possible. So the next perfect square that will look like will have prime factors like this: 2 power 4 multiplied by, now there's nothing wrong with 2 power 4 by the way, because the power here is even. But there is a problem with 5 power 1, because if a number has to be a perfect square, the power on 5 should not be 1, instead it should be 2. Why? Because 2 is an even number and 1 is not. So this number now is a perfect square, and what did we multiply 80 in order to obtain a perfect square? You can see that we increased the power of 5 by 1, so that was done by simply multiplying it by 5. So what is k equal to? K is equal to 5. K is the number that we will have to multiply 80 with in order to make it a perfect square. Now if you're clear about this, that's fantastic. In case you're not, nothing to worry about. We're going to do another example. So the number that I'm going to take this time, this is example 2 by the way, the number that I will take now is, let's say, 125, right? So 125, if I were to write as a product of its prime factors, the only number that I can divide it, the only prime number that I can divide it with is 5. So 5 times 25 is 125. I can divide it by 5 again, so 5 times 5 is 25. I can divide by 5 again, so 5 times 1 is 1. So 125 can be written as 5 cubed, or simply 5 into 5 into 5. So let's say the question tells me to multiply 125 by k so that it becomes a perfect square. 125 into k is a perfect square, and it asks you to find the smallest value of k. So 125, as we saw, can be written as 5 cubed. If I want to make this number a perfect square, that means the power on 5 should be even, and the next even number that comes after 3 is 4. So how can I make 5 power 3 equal to 5 power 4? I can simply do that by multiplying by 5. So coincidentally, the value of k here is also equal to 5. Let's do one more example. Let's say the number here is 180. So if I write 180 as a product of its prime factors, let's see what that looks like. 2 times 90, 2 again, 2 times 45, and now 3, so 3 times 15, now 3 again, so 3 times 5, now 5 again, so 5 times 1. Now let's say that the number I take is 75. So let's start dividing 75 by, we can divide it by 5. So 15 is 75. 5 times 3 is 15, and 3 times 1 is 3. So 75 can be written as 5 square times 3. So the next perfect square will look like 5 square. There's nothing wrong with 5 square because it's already even, so we're just going to ignore that and write it as it is. But 3 power 1, however, is not a perfect square, so the next perfect square will be 3 squared. So how can I make 3 power 1 equal to 3 square? I can do so by multiplying it by a 3. So what's the value of k equal to? This right here is the value of k, or this right here is the number that I will multiply 75 with in order to make it a perfect square. So the value of k is equal to 3. Now a full length question of or a past paper question will look like this. It's going to give you a number which is already going to be written as a product of its prime factors, say 2 cube times 5 square times 3, and it will ask you to find t, find the smallest value of t, find the smallest value of t such that a into t is a perfect square. So in order to turn this number into a perfect square, first let's just write it down as it is, 2 cube times 5 square times 3. Now let's try and be more systematic here. So a times t should look like this. The power on 2 should not be 3, instead it should be 4. Now there's nothing wrong with 5 square, so I'll just copy that down as it is. And 3 power 1 is not a perfect square, so the perfect square will be 3 squared. So how can you increase the power of 2 from 3 to 4? You can do it by multiplying it by 2. And how can you increase the power of 3 from 1 to 2? You can do that by multiplying it by 3. So what's the value of t equal to? The value of t is simply equal to 2 times 3, which is equal to 6. So this is how you can turn any number into a perfect square. Long story short, in order to turn a number into a perfect square, the powers should be even. Okay, now let's talk about perfect cubes, how you can turn a number into a perfect cube. And in order to do that, let's look at what perfect cubes look like. So 8 is a perfect cube. 8, when written as a product of its prime factors, is equal to 2 cube. Similarly, 64 is also a perfect cube, and if you write 64 as a product of its prime factors, it will look like 2 power 6. 27 is also a perfect cube. This will look like 3 power 3, and we have 216 is also a perfect cube. This will look like 2 cube times 3 cube. Yeah. So you can see that the powers here are, they're not always equal to 3. In fact, they are multiples of 3. 3 is a multiple of 3, 6 is a multiple of 3, 3 again multiple of 3, and so on and so forth. So if I want to turn a number into a perfect cube, the powers should be multiples of 3. So let's write that down. In order to make a number a perfect cube, all powers should be multiples of 3, and all powers on the prime numbers. Okay, you have to keep that in mind, that the number has to be prime. Oops, sorry. So let's say we're given a number, and that number is, let's take let's say we have 120, right, just a random number. So the question will look like this. It's going to ask you to write 120 as a product of its prime factors, and then it's going to tell you, this is going to be the first part. Next part is going to ask you to find the smallest value of p such that 120p is a perfect cube, right? So let's begin with part A, where we write 120 as a product of its prime factors. We'll start dividing it by 2. So 2 times 60, we'll divide by 2 again. 2 times 30, we'll divide by 2 again. 2 times 15, we'll divide by 3 again. 3 times 5, we'll divide by 5. So 5 power 1. So 120 we can see can be written as 2 cube multiplied by 3 multiplied by 5. Alright, so clearly we can see that this number is not a perfect cube, and we can further understand that by looking at the powers on the prime numbers. Now as far as 2 cube is concerned, there is absolutely nothing wrong with 2 cube, so we're just going to copy it down as it is. Why there's nothing wrong is because the power is already a multiple of 3. Now 3 has power 1 and 5 also has power 1. So ideally, if 120p is to be a perfect cube, the power on 3 should be 3, and the power on 5 should also be 3, the smallest power. Or although it can be 6, 9, 12, but the question will always give you a certain condition, and that condition will be that you're supposed to find the smallest value. So now, if you want to bump 3 power 1 to 3 power 3, that means you'll have to multiply it by 3 square. And if you want to bring 5 power 1 up to 5 cube, that means you will also have to multiply this by 5 square. So what is the value of p equal to? The value of p is equal to 3 square times 5 square. So let's evaluate that. So that's going to be equal to 9 times 25. And what's 9 times 25 equal to? That is equal to 225. Yeah, so 9 times 25 is equal to 225. So this is how you can turn a number into a perfect cube. If you got this right away, that's fantastic. If you didn't, let's do another example. So let's say you're given a number b, which is already written as a product of its prime factors, and it looks like 3 square times 5 cube times 7 raised to the power of 5, right? And your job is to turn this number into a perfect cube. So, and you can multiply it by t, and again the condition is that you have to find the smallest value of t. So what will the perfect cube look like? 3 will have power of 3, 5 cube is fine since it's already a perfect cube, 7 power 5 should be 7 power 6. So how can you do that? How can you bring 3 power 2 up to 3 power 3? You can do that by multiplying it by 3, and you can, there's nothing wrong with 5 cubes, so you don't need to multiply there. 7 power 5 needs to be increased to 7 power 6, so we can do that by multiplying it by 7. So what's the value of t equal to? The value of t is equal to 7 times 3, which is equal to 21. So this is how you can turn any number into a perfect cube. I hope everything's clear so far. In case it's not, make sure that you write your query down so that you can ask me in the next class on Saturday, inshallah. Alright, now we're going to talk about factors and multiples. So this is something that we discussed in the last class as well, and we're going to do this with a lot more detail now. So 6 is a multiple of 3. Now why is that? Let's find out. And in order to do that, let's write 6 as a product of its prime factors, and let's write 3. Well, there's no need to write 3 as a product of its prime factors since it's going to be 3 only. So 6 multiple, remember, is in the numerator, and factor is going to be in the denominator. Alright, just remember it like this, m upon f. So 6 can be written as 2 times 3, and 3 can be written as, well, 3 can be written as 3 only. So the reason why 6 is a multiple of 3 is because when we simplify, and that means when we start reducing or cancelling out the prime factors of both the numerator and the denominator, we see that there is nothing left in the denominator, but there is something left in the numerator, and that is equal to 2. So basically what happens is all the prime factors in the numerator cancel out all the prime factors of the denominator, and there is still something left in the numerator as well. So let's do another example. Let's say I tell you that 24 is a multiple of 6. So if I were to write 24 as a product of its prime factors, I can do that by 2 times 2 times 2 times 3, and 6 can be written as 2 times 3. Now again, the reason why 24 is a multiple of 6 is because when we start reducing, we can see that all the prime factors of the denominator get cancelled out. The 2's get cancelled out, the 3's get cancelled out, and we have something that's left over in the numerator, which is fine, and that is equal to 2 square or 4. Okay, so we can see that this is why 24 is a multiple of 6. Now if I say that 30 is a multiple of 8. Now we can see that this is clearly not correct. This is an incorrect statement because 30 is not a multiple of 3. We cannot divide 30 by 8. However, if I allow you to multiply 30 by a certain value, which is k, and I tell you that after multiplying that by value, the 30k is a multiple of 8, and I tell you to find the smallest value of k. Now how can we do this? So the first thing that we'll have to do is we'll have to write down 30 as a product of its prime factors. So we can do that by 2 times 3 times 5, and we're just going to write k as it is, and we're going to have to write down 8 as product of its prime factors, so we can simply do that by 2 times 2 times 2. Here it's better if you write the number in the expanded form. Instead of writing 2 cube, I'll write 2 times 2 times 2. And why is that? You'll understand in a couple of minutes. So we're going to start simplifying and see what are all the numbers that we can cancel out. So we can see that there's a 2 in the numerator and there's a 2 in the denominator. Now the problem here is that we still have 2 times 2 or 4 that is left over in the denominator. So how can we make sure that 30k is a multiple of 8? We can do that by making sure that there is nothing left in the denominator. So the smallest value that k can take here in order in a way that there is nothing left in the denominator is 4. Why? Because if k is equals to 4, what's going to happen is that assuming that k is 4, these two and these two will get cancelled out. Now k can be anything that's greater than 4. That means it can be 8, it can be 12, it can be 20. But the question has given us a certain condition, and that condition is that we're supposed to find out the smallest value of k. So the smallest value will always be whatever is left in the denominator after you have reduced them. So what is left in the denominator? It's 2 times 2 is left, so the smallest value of k is going to be equal to 4. Now we can further test this by multiplying 30 by 4. So that is equal to 120, and we can see that 120 is a multiple of 8. Now, of 8. Now, if you've understood this, that's great. If you haven't, nothing to worry about. Let's try another example. Alright, let's say you have 96 and you're supposed to multiply it by a certain value, t, such that 96t is a multiple of, let's say, 36. And again, your job is to find the smallest value of t. Again, here also the condition will be that the question will always ask you to find out the smallest value, never the largest value. And this, by the way, is example number 2. So again, we start writing 96 as a product of its prime factors. So this is something that I don't remember, so let's just write it down. So 2 times 48, 2 times 24, 2 times 12, 2 times 6, 2 times 3, 3 times 1. And let's do the same for 36. Well, 36 I know can be written as 2 square times 3 square, or 2 times 2 times 3 times 3. So let's write 96 as 2 times 2 times 2 times 2. How many 2's do we have? 1, 2, 3, 4, 5. Yeah, so 1, 2, 3, 4, 5 times 3 over 36, which can be written as 2 times 2 times 3 times 3. And don't forget that there's a t in the numerator as well. So again, the process is exactly the same. We're going to start reducing, and we're going to start cancelling out basically and see whatever is left in the denominator. So the 2's get cancelled out. Actually, there are 2 2's that get cancelled out, and 1 3 of the denominator with 1 3 of the numerator. Now we can see that what's left in the denominator is 3, and if I want to get rid of this 3 here, t has to be a multiple of 3. So the smallest multiple of 3 is in fact equal to 3. So the value of t is going to be equal to 3, the smallest value. The largest value could be anything, any greater. Well, the question won't ask you for the largest value, so there's no point in debating about that. So let's just do one more example. And in this example, I'm going to twist the term slightly. Now here the question will say that find the smallest value of m such that, let's say the question says 90m is divisible by, let's say, 24. Okay, so again we're gonna have to take 90 and write it as a product of its prime factors. So let's do that quickly. So 2 times 45, 3 times 15, 3 times 5, and then 5 times 1. And let's do the same for 24. 2 times 12, 2 times 6, 2 times 3, 3 times 1. So 90 can be written as 2 times 3 times 3 times 5, and let's just put an m here so that it becomes 90m. And 24 can be written as 2 times 2 times 2 times 3. So again, we're going to start cancelling out the numerator and the denominator and see what are we left with in the denominator. So these two get cancelled out. 3 and 3 get cancelled out. So what do we have in the denominator that's left over? It's 2 times 2, which is equal to 4. So the smallest value of m is equal to 4. So this is how you can make one number a multiple of another, or one number divisible by another. You just got to make sure that there's nothing left in the denominator, and after you've written both the multiple and the factor as a product of its prime factors, what you do is you reduce the two, you start cancelling out, and then whatever is left in the denominator is your smallest possible value. After this, I have a certain worksheet which I'll attach or share in the WhatsApp group, and I want you guys to attempt that worksheet, do as many questions as you can, so that we can discuss the queries, if you have any, in the next class, inshallah. So see you then, take care, and my apologies for not conducting the class live, but hopefully this will make up for it. So see you guys tomorrow, inshallah. Allah Hafiz.